Great. Well, good morning. That was quite a warmer act for you, I think, Rene.
It was.
I'm delighted to be here, to be joined by Rene Haas, who is president of Arm's IP Products Group, a post he took up in January 2017. A lot of job titles can conceal as much as they explain. So can you first start? Exactly what do you do at Arm?
Sure. Thank you, and good morning, everybody. And thank you, Herman, for the great warm-up and description of Arm. So Herman mentioned a little bit about our company. We are a provider of intellectual property to semiconductor companies. So our primary products are IP, CPUs, GPUs, a number of different products. And I essentially manage the group that is responsible for the development, engineering, marketing, sales of those products.
Right. Now, on your website, and I think as Herman briefly showed, Arm claims to be the technology at the heart of about 100 billion devices, including sensors, smartphones, and servers. I wanted to start with just a kind of definitional issue, because, I mean, that is way more connected devices than people like Gartner, other people suggest are out there. So could you just define what is your idea of a connected device?
Sure. So a bit about our business model. So again, we license intellectual property to companies who build semiconductor components that go into all type of devices, whether it's mobile phones, set-top boxes, automobiles, et cetera, et cetera. So just by way of context, as Herman mentioned, the company has been around for about 25 years, a little bit over. In the first 20 years of the company, our semiconductor partners shipped cumulatively about 50 billion components. In the 4 years subsequent, 2013 to 2017, another 50 billion was shipped by our partners. So essentially, in the first 20x years of the company, a grand total of 100 billion chips. In this last year, in 2017, our partners shipped another 20 billion chips. So the numbers are very, very large. They're growing and growing and growing. And they are increasingly all connected, whether it's a mobile phone, whether it's a Nest thermostat, whether it's autonomous driving. These devices are not only intelligent, but they're increasingly becoming connected to the internet.
And you're suggesting really that we're only at the beginning of this process. I think there's a company forecast that there will be 1 trillion connected devices by 2035. So we are moving incredibly fast.
Yes, this conference is sponsored by Softbank, and the CEO and founder of Softbank is Masayoshi Son. And he talks about 1 trillion connected devices by 2035. And if you look at the math in terms of the trajectory of just the ARM-powered devices, it's really not that far off. So that type of vision, we think, is very, very realizable.
What does the world look like with 1 trillion connected devices?
Yeah, well, I think Herman showed just some of the examples that are starting to spawn, whether it's autonomous driving, intelligent machines, things of that nature. One area that I just want to expand a bit on, and Herman mentioned health. Health is one area that is ripe for expansion in terms of not only connectivity, but intelligent devices. Now, I'll give you a small example of a very interesting product called, by a company named Respro, that does an intelligent inhaler. So you ask, well, what is an intelligent inhaler? Well, think of an asthma device where, and we're all familiar with those, we've seen people who have taken those, where the patient who has asthma has a condition, they use the inhaler, they ingest it, and essentially that's how they can maintain the proper condition. The healthcare industry is a very open loop system relative to when a doctor diagnoses a condition, prescribes a drug, and then has feedback as to whether that's been taken. So this company, Respro, has developed an intelligent inhaler, which essentially is a machine learning-based device. It has a small ARM CPU. It has some intelligence in terms of compute algorithms. It has a Wi-Fi connection. And what it does is when the patient inhales, it actually sends feedback to the doctor when the dosage was taken, when it was taken, how much was taken, and essentially it allows the doctor on a real-time basis to monitor the effectiveness of the drug. That's just a small little example of something that's in the market today, and you can just imagine what that's going to look like going forward. Again, to Herman's example of all of the amount of dollars that are spent in terms of treating ill patients, there's just a huge opportunity on patients who are not ill, keeping them well, et cetera, and Respro is just one small example.
So how far off the day do you think we are that we will have permanent real-time monitoring of all our health systems? It's always seemed to me rather bizarre that we spend a huge amount of time having real-time analysis of aeroplane engines when similar technology could monitor all of our kind of bodily functions?
Yeah, it's a great question. There's a lot of energy going into this right now. The technology is getting to the space where you can have intelligent type of diagnosis, you can have real-time connectivity, and you can send data in a low-power situation. So one of the things that's very important for, imagine, again, in an asthma inhaler, is that this is not plugged into the wall. It needs to be battery-powered. It needs to last a long time. And you have to have machine learning in the device. We now have the capabilities to do all those things. So the technology is getting there very, very quickly. And it's one of the things that we talk about, moving machine learning to the edge, if you will. So again, Herman talked about some new technologies that have a lot of graphics horsepower or computing horsepower, but they do consume a lot of power. And in these health devices or end devices, you want intelligence, you want connectivity, but you need low power, and that's a big emphasis for us. There also are, candidly, a lot of regulatory issues. There's government issues, there's privacy issues relative to the data. Those are big problems that do need to be sorted out. A lot of people are now working on them. And again, the health industry is one that's very, very fragmented relative to the ecosystem, when it's the connection of the hospitals to the doctors, to the patients. But the opportunity is so large that I think it's inevitable to be sorted out.
Mm-hmm. Now, there's quite a lot of discussion on the stage here yesterday and elsewhere at the conference about Moore's law and the original observation that the number of transistors in a dense integrated circuit doubles about every 2 years. I think it was Gordon Moore's original definition of it. And the argument that this is slowing down. Is that right, and does it matter?
It's right, and I'm not sure it matters.
Can you explain why?
Yeah, and here's why. Again, Herman did a nice lead-in to this question. Every number of years, we get into a paradigm where the way that computers work shifts, whether it was CISC to RISC, and now RISC to GPUs, to neural network processing, et cetera, et cetera. As transistors shrink, and as more performance can be manifested, the laws of physics tend to slow that down. So if you are using those transistors for conventional compute methods, yes, Moore's law is coming to an end. However, if you can use those transistors in different ways in different compute models, such as graphics processing, neural network processing, et cetera, the power of the computer can go on and increase. And that's what we're seeing right now. So yes, we have a physics issue in terms of Moore's law relative to transistors. But on the flip side, all of these new exciting areas around processing is going to open up a brand new, huge opportunity.
The other big physics question in the computing world is clearly quantum computing.
Yep.
How rapidly do you think that is going to come in?
Yeah, it's a great question. For those not familiar with quantum computing, and again, Herman talked about an example of digital computers using zeros and ones and transistors of sources and gates and drains. Quantum computing is taking the next level of physics to essentially have transistors and atoms operate in a very, very fast fashion when you lower the temperature to something crazy like 273 degrees minus centigrade or 0 degrees Kelvin. Obviously, there's a big physics issue with being able to cool computers to that level. However, there's a lot of work going on to advance that. Companies like IBM and Microsoft are working in this area. It's not a few years away. It's probably tens of years away. But when that happens, it's going to be a huge, huge revolution in terms of computing.
Okay. One of the other revolutions that you were alluding to earlier is edge computing, having a lot more computing power on your device. What is that going to mean in practice to the people in the audience here? How are they going to notice the manifestation of edge computing? Yeah,
it's a great question. So again, all of these areas around neural network processing or parallel processing, et cetera, the balance is power and heat and energy. So one of the big emphases we have at ARM is around low power, small footprint, et cetera. Being able to have intelligence at the edge is going to enable a whole new set of use cases, whether it's that Echo device or the Alexa devices to become far more powerful, that can be placed in different areas of the home, whether it's LiDAR or radar in the cars. You know, people look at the automobiles and think, well, gee, it's a huge vehicle, it's a lot of power, there's a huge amount of area to do computing. But actually, when you think about weight, when you think about an electric vehicle, when you think about mirrors and density, Being able to put small little edge computers that can make decisions very, very quickly in that car in areas that you can't fit a very high power heated CPU is really, really important. So this notion of edge compute and intelligence is going to find its way into really almost all the applications.
Right. Now, in this world of massively connected devices, this is going to generate an unbelievable amount of data, which is going to be the feedstock for machine learning and AI systems. What do you see the most promising areas for that data use?
Wow, that's a great question. Again, I think we are on the cusp of some very, very interesting revolutions on the technology side. So 5G is right around the corner. And what 5G is going to enable is not only a ability to transfer and move huge amounts of data much more quickly than 4G. So the performance will be 10 to 50x depending on the networks, but also the latency, i.e. the amount of time it takes from the device to go to the cloud and back will be much shorter. Well, what does that mean exactly? It means that real-time decisions can be made around autonomous driving, around robotics, things that don't have to go to the cloud and back. And I think the other big thing on 5G, and we learned this with 4G, is when these new technologies happen, when we get into these sort of disruptions, the applications and the use cases that come from it are frankly very hard to predict. You know, Herman talked about Uber and autonomous driving. You know, when you think about the Uber business model, you know, things like GPS, location tracking, ease of use on a mobile device, that simply was not available on 3G. You could not have done that on 3G. When we got to 4G, 4G LTE, suddenly all these use cases came up that we couldn't really imagine that were spawned with the 4G performance. That's going to happen with 5G. 5G is going to spawn a huge amount of new applications area that it's really, frankly, hard for us to predict. But what history has shown us is that when these disruptions happen, there is large opportunity. So when you take everything that's going on with machine learning and AI and neural network processing, and then when you layer 5G on top of it, I think we're going to see some disruptions that are going to be, you know, hugely exciting.
Now, we're obviously entering an incredibly connected world, but that also means it's an incredibly complex world. And so Nigel Shabolt, who was speaking on the stage yesterday, his book, Digital Ape, one of the concerns that he expresses in that book is that we're moving into a world of hyper-complexity. We are creating these systems which are unbelievably complex, which no one really understands all of the interconnections. And we've seen an example, let's say in 2008 with the global financial crisis, of what happens when we create systems that we don't fully understand. Is there that danger in your kind of world that we are just going to create this web of interconnections that we don't really understand what is happening and we don't understand the spurious correlations that we're deriving?
Yeah, I think there is certainly the risk of that. And I think one of the things, again, with 5G and machine learning, with the vast amounts of data that are going to be generated, we're going to have new areas and methods to control things like security. And what you may actually see is the classic what's old is what's new is old. In other words, devices may become more localized. You may have a cloud. There may be a cloud, for example, inside this room, where folks who may be looking at maps or things on the internet may not be actually hopping to a data center that's sitting somewhere in the English countryside. That may all happen inside this room. So what's the benefit of that? A more controlled environment. Security will be potentially easier to manage in a more closed environment because of the vast amount of data. Security is a huge thing that we look into at ARM, just given the vast amount of products that we're involved in. It's a very, very large degree of emphasis for us, but it also requires the entire ecosystem. Security is not just a ARM issue. It's not just a semiconductor partner issue. It's not just a device maker issue. It's everybody inside the ecosystem. So to your question in terms of all the complexity that is going to come out in the next number of years, it's really going to require the community to come together to solve and address these security issues on a real-time basis.
Right, now let's dig a bit deeper into those security issues, because clearly if everything is connected, we want to be damn sure that the people who are collecting this data are keeping it safe. And your own surveys, I think at ARM, suggest that 75% of people are concerned that autonomous vehicles might be hacked. And there's a very scary video on YouTube of that happening. 60% of people are concerned about the criminal use of AI technology. How do we stop these bad things happening?
Yeah, it's a great question. In autonomous driving in a car, for example, some of the things that we have to do is make sure that the computers inside the car are isolated, right? So for example, you may have an instrument cluster that is powered by a GPU that looks very nice to the user, yet if that operating system goes down and an instrument cluster goes down or hacked, you need to make sure that the warning lights that still go on. Now, someday when no one's driving the car, maybe that's less of an issue. But today, isolating those units, making sure that you have security architectures that are inside the device is really, really important. We're doing a lot of work ourselves around a platform. We call it Platform Security Architecture, PSA, funny acronym, around essentially defining a set of conditions and compliance such that when an end user or consumer sees a device that's PSA compliant, they'll have a level of assurance that it meets a certain level of security standard. That's just one small example. There's a lot of things, though, that the industry needs to do to get behind this.
Okay. And there's been a lot of debate at the conference about how AI can be used for good. You have a critical role in the center of this ecosystem. How are you ensuring at ARM that AI is used for good?
It's a great question. I mean, you get into the areas of social norms and behavioral type of areas. Again, I think this is something that we are all just trying to figure out as an industry. I think getting the right groups and people together collectively to have conversations about what makes sense. It is a very new area. Again, I think security is going to underpin a lot of this, making sure that partners in the ecosystem, whether it's the friendlies and the unfriendlies, we're all in this together. We have to go off and solve this collectively as an ecosystem. And I think, in terms of the AI for good or for bad, that's a very key area.
Mm-hmm. Final question really is about how ARM operates. We were hearing from Rajiv Misra yesterday of Softbank, who made the big investment in ARM, that Masayoshi Son, who you were talking about, has this great vision of the Internet of Things and how this interconnected world is going to work, and that they very much want ARM to make a bet on that long-term future, and therefore are encouraging you to invest for that future, and even at the cost of sacrificing short-term profits. Is that happening? Are you going back to Mr. Son and saying, well, actually, we're not making so much money this year because we're investing for the future?
Yeah, no, it's a great question. I think he'll care that we're not making very much profit until we're really not making profit, and I'm sure he'll really care about it. But seriously, so we've been part of SoftBank now since September of 2016. Time really flies. I'd say probably the single biggest change for ARM under SoftBank prior to the SoftBank acquisition, publicly held company, FTSE exchange, had to meet the demands and questions of the investors every quarter. Under SoftBank, we have a higher degree of freedom to invest, a higher degree of freedom to invest in some of the future technologies that we just talked about here. And frankly, it's been great. They are true to their word in terms of investing in the long term. They give the management team a lot of freedom to operate. And so long as we hit our short-term objectives, I think driving for the long term is consistent with their goals for us.
Okay, and the final question is that your latest corporate announcement was that you had sold your Chinese arm to local investors, or a controlling stake in that to local investors, which had caused some concern about whether there was a possibility of kind of transfer of IP. Can you just clarify that? What was the intent of that deal, and what was the consequence?
Yeah, it got a lot of news over the past week. I think part of that was due to a SoftBank filing that disclosed the financials behind that. We've been working on this for a couple of years. So this is a joint venture that is 49% owned by ARM, 51% owned by China partners and investors. For those who are familiar with sort of the broad China outlook, the China government is being very, very aggressive in terms of trying to develop their own semiconductor industry. They want companies that are indigenous and controllable. What we felt as an IP provider would be that by creating a joint venture, still providing the technology that ARM has today into those partners, but also allowing an entity in China to develop products for the China market would best position us for success. So it did get a lot of news in the last week, but it wasn't something that we came up with in the last couple of weeks. We've been actually working on it for a couple of years. We signed an MOU about a year ago, and then the transaction just closed about a month ago.
All right, wonderful. Well, we have run out of time, but many thanks, Rene, for your fascinating insights into the world of computing.
Thank you.